Hi guys, and welcome back to another Gen Code lesson. We're going to continue with the Python track today, and today we are doing Python lesson 10. We're going to be doing exceptions. So this one is very important, but also shows you a little bit about how we troubleshoot and all that kind of stuff with our code when something goes wrong. So that's where exceptions come into play. So in the previous few lessons, we did classes and objects and strings and methods. So if you haven't checked those videos out, please do so on gencode.us, or you could go on the YouTube channel and go onto the Python track and look up those lessons as well. So without further ado, let's just go right into the next lesson, which is lesson 10, and we're going to be doing exceptions. Okay, so before we go into what we're going to do about what kind of exceptions Python has, let's just go talk about the general knowledge of it. What is an exception in Python? So an exception is an error which happens at the time of execution of a program. So when we run a program, like when we write a code, right, and we run it, right, and as we run it, remember Python reads the code as we execute it. So once we run the code, if it throws back an error, it will let us know what type of error, right? So whether it's a syntax error, a type error, a name error, it will let us know what type of error. And at that point, when we see that type of error come up, we have to troubleshoot, right? So troubleshooting means we need to figure out what we have to do with that. What did we did wrong in our code that Python threw back an error? So we go back to the code, and it could be like something simple as misspelling a variable name or forgetting to put the quotation marks around a string. Something has to have something we did wrong in our code that led to Python throwing an error or an exception when we ran a program. So while running a program, Python generates an exception that should be handled to avoid your program to crash, right? So instead of the program to crash completely, it'll just throw back an error and tell you, hey, there's something wrong with your code, right? Python's going to tell you there's something wrong with your code. You need to fix it, right? It's just going to do that instead of just crashing altogether and you don't know what happened, right? So that's another reason why Python or any programming language generates an exception, right? So it helps to handle it. It handles the execution of the program. In Python, in the Python language, exceptions trigger automatically on errors, or they can be triggered and accepted by your code, right? So again, it just Python just does that always. And with exceptions, we need to always remember you're going to always have errors in your code. There's no perfect programmer in the world, right? So whenever we have like misexecutions or something's typed wrong, or maybe you just didn't you just capitalized the word which shouldn't have been capitalized, there's something had to have happened in the Python code, and we all make mistakes. We're human beings, so there's no perfect programmer. So exceptions helps, but there are good troubleshooters in the world too, right? So if you really want to become a good troubleshooter when you write your code or when you're a professional programmer, you want to know exceptions, right? Because this will help you in your daily life, right? When you're at a job, right? You want to know what you did wrong when you wrote a code, and then you need to figure out, you have to troubleshoot it, right? You need to figure out what you did wrong so you could fix it, and so that you could submit it to your company, and it works, right? Because you don't want to send a code that does not work, right? That costs a lot of money, and they have to come back and you have to fix it, and it's just a waste of time and a waste of money. So this is a good reason how you could troubleshoot is by doing exceptions, and that's why I think this is an important lesson. So exception handling, right? So Python uses exception to communicate errors, right? Exception is an object that indicates an error or exceptional condition, right? So anything that seems like Python cannot handle something, right? And something looks completely wrong, it will throw back an exception, right? Because it indicates there's an error. And code, especially explicitly rises an exception by executing a raise statement, right? So that's why we typically use exception. And if a program does not handle an exception, it terminates within the error traceback message, right? So if it cannot handle an exception, it'll just terminate it, right? With a error traceback message that it couldn't handle an exception, so it's just gonna throw that message back out, which is, I don't know, completely fine as well if there was something wrong with your code. So here are some of the common examples of exceptions. These are some of the common reasons why your program will throw back an exception, right? Division by 0, right? So if you think about it in a math class, right? We never divide by 0, right? When you divide by 0, what do your teachers always say? It's always undefined, right? Because you can never divide by 0, right? Anything when 0 is in the denominator, you cannot divide it. Well, in programming, if you divide by 0, it's going to throw back an exception that's called division by 0, right? Because you cannot divide by 0. Another reason an exception could be thrown is maybe because your program's trying to access a file which does not exist. You probably wrote a file in your program that does not exist in your directory. That could be another reason why there could be an error. You could be adding two incapable types, right? Which is like I showed you in the early lesson, to probably all the way back to lesson 3, I think, when we're doing data types, right? When you add up two different data types, right? Let's say you add up a string and a integer, right? Well, you can't add a string and an integer, so they'll throw back an error, right? Because it doesn't, you can never add up a string and an integer. You have to convert one of them back into a string, so you combine it. Another one is accessing an index of a sequence not in range. Again, back in lesson 3, and I think back in lesson 3, and recently back in lesson 8, which was like 2 weeks ago, we talked about indexing, right? When you index a string or a list and it's not in the range. So your index goes from, let's say, remember, indexing in program is zero-based indexing, meaning your index always starts at 0. So let's say your index starts at 0 and you have let's say you have 4 words in your list, right? Let's say you have a list and you have 4 words in it, right? But you start the first in, let's say you want to find, say Python, give me the index at index 6, right? Well, it's only 4. And that means the index only ranges from, that means index will be from 0. And I'm on 0-based indexing, that will be from 0 to 3, right? So there is no index 6. That means your list, that index is out of range. So that's another reason why Python will throw back an index error, right? That's another exception Python could throw back. And maybe finally, we could be saying, we're looking up a key in the dictionary that does not exist, right? There's a key in the dictionary that does not exist, and it'll throw back a key error, which is another exception in Python. So these are some of the common reasons why Python could be throwing back an exception, but there could be many more. These are just the common ones. There are a lot more. These are like a couple of examples of why Python could be throwing back an exception for your code. Again, maybe a lot of you are wondering, why do we use exceptions? So here are some of the reasons why we use exceptions, right? The first bullet point. Exception handling allows you to separate error handling code from normal code, right? So it helps you, like a code that has tons of errors from normal code, right? So it gives you an idea where the errors happening, right? And then you can separate some of the working code from the not working code, right? An exception in Python object which represents an error, right? So this tells you, handles an error, right? It's just telling us something's wrong with the code, you need to fix it, right? An exception is a convenient method for handling error messages, right? So it's a good way to troubleshoot again, right? And raising an exception helps you break the current code execution and returns the exception back to the exception until it's handled, right? So it just breaks your code, throws back a message, tells you there's an exception, tells you what type of exception, and then you would have, then it's an easy way to diagnose what's wrong with your code, right? So if it said, let's say it said index error, right? Well, then I could go back into my code and troubleshoot that, right? Index error means something's wrong with the index, right? This index that's went out of range or something. So I could go back and I have to look at that particular snippet of the code, right? I don't have to look at the entire code. I just gotta go into the place where Python's trying to find something in range, right? In my list, right? Because we're looking at index error. So I have to do something with indexing. So I could just go to that part of the code. And it really does help, because when Python throws that back, it gives me a good way to go back and figure out what happened here that Python does not like, right? So that's a good way to why we use exceptions. It helps us troubleshoot. That's the biggest thing. It helps us troubleshoot. I cannot imagine you executing a code and then it doesn't give you back any messages or anything. It just crashes, and you'll be like, "Huh, what happened?" Right? You wouldn't even know where to start, right? You'll have to go back to the entire code, and it'll just get frustrating, right? Because you will never know why Python's throwing it back, and that's why exception handling or exceptions are a good thing in computer science or computer programming. And if you want to become a good software engineer or a software developer, you really want to be good at troubleshooting your code. And that's why this is a very important lesson. I'm going to keep saying it's a very important lesson because it is. So let's talk about a statement, right? Let's talk about the try statement, right? So the try statement provides Python exception handling mechanism, right? It's a compound statement, and it could take in two different forms, right? The try clause followed by one or more except clause, right? So if you did Java, you looked at to handle exceptions, you use the try catch block, right? Python has a similar one, right? It has the try block, it has the try except block. Instead of catch, we use except in Python. And the try clause follows by exactly one finally clause. It could have, that's another way you could do it. That's the second form it could take, by exactly one finally clause. You cannot have multiple finally clauses, one finally clause. And here's the formatting, right? So here's the try statement, right? This runs this as a normal part of the program, right? Try is a normal part. I remember when I said, like, remember in the previous slide, I talked about it separates normal code from it separates normal code from what you call exceptional code, right? This is what I'm really talking about in this picture right here. So here's the try, right? The statement, this statement under the try block says run this as a normal part of the program, right? That's the normal code, right? Run this as the normal part. Except, right? Here's the exception. This is where the exceptional code happens, right? Execute this when there is an exception, right? So it's basically, you could say kind of like, if you think of an if else, right? If this happens, do this, right? If it doesn't, then go to the else statement and do this, right? So something's good, run this as a normal part of the program. If anything, if it's all good, just run this, right? If there is an exception, go to the except block and execute this when there's an exception, right? So whenever there's something wrong with your program, execute this part of the statement. Execute these statements under the except block. I'm not really going to go that much into the finally block yet. I think that's another time we could talk about it, because we rarely use this in Python, the finally block. There's a lot of other conditions we use this, but for now, you just want to really focus on this one. This is the key one right here. Try except. And here's the syntax of it, right? Try, the statements, the except, and then you have to say what exception, right? You're trying to handle, and then again, you write the statements. So similar to an if else, I think, but works differently. And we're getting into the good stuff now, right? We're talking about the built-in exception classes in Python, right? So here's some of the basic, here's something known as the base exception, right? So base exceptions is known as the king of all exceptions, right? It's the main exception. It's the king, right? Like it's top of the exception, of all exceptions, right? And here are some examples of some of the base exceptions, right? So one base exception is the standard error, right? So this is a base class for all built-in exceptions, right? And some of the standard error exceptions are the arithmetic error, right? So you could get a arithmetic error, meaning like a math error, right? So something known as, you could get a floating point error, you could get an overflow error, and zero division error. I think we talked about dividing by zero. You'll get this one. It's the zero division error. That's one the arithmetic errors that you could get when there's something wrong with your code. You can get one of these as an example. There's an attribute error, right? So on an attribute reference or assignment failure, right? There's an environment error, and environment errors do not occur in Python, they occur outside of Python. So this could be something with your PC, right? It could be an IO error, it could be an OS error, or it could be a Windows error, depending on if you have a Mac or a Windows PC. Import error, right? On failure of an import to find a module name. So if you do import, let's remember we talked about import turtle. What turtle is a built-in function. Python's not going to throw back in the air for that. It knows what turtle is. But if you just if you import something, let's say you spelled turtle wrong, right? Let's say you spelled without the or, then it's not going to understand what that is. That will be an import error because it cannot find that module. And that could just be simply just misspelled the word, or it just does not exist in the Python library. The lookup error, right? So these are the lookup errors, right? So this is something I was talking about, indexing or key errors, right? So some of the lookup errors could be the index error, right? Again, that's being repetitive already on that, but it's basically on out of range sequence subscripts, right? So anything that's out of range on a string or a dictionary, an index that's out of range in a, sorry, not a dictionary, on a list or a string, that will be an index error, right? Index error is only called when something's out of range. Indexing is out of range. I don't think we talked so much about key error, but key errors happen on dictionaries, right? So when you have a key in a dictionary, remember you have a key value pair. If you're looking for a key in that dictionary and that key does not exist, then this Python will just throw back an exception known as the key error. I could show you that example actually on PyCharm. Name error, right? So name error is like something like unbound local error, or maybe something you just misspelled a variable or something. You get back a name error because that name does not exist in your code. Syntax error happens all the time. That's one of the bigger errors, right? That's like when your code does not run at all, right? There's something up with it, right? But there could also be another reason why you could get in syntax error. You could get indentation, right? You'll always get back a syntax error when you Python. Remember, Python's highly strict on indentation, right? So if your indentation is not in the proper spot, you could get back a syntax error, right? And it will say indexing or phrasing is not correct, right? So it will tell you your index is not right. You have to fix it. Your indentation is not right. It's going to tell you to fix that. Remember, Python's heavily on indentation, so you really need to make sure your code's indented properly where it needs to be. And tab error, that means just, we haven't really seen so much of that, but similar to index error, but tab error is more like improper spaces and tabs. You're not going to deal with that often, but that could be another case why a syntax error could be thrown. But mostly it's the indentation is why we always get syntax errors, or it's just the code just does not make sense that Python just doesn't know how to read at all. That's another reason why you can get a syntax error. Probably one of the reasons, probably the least explained error, right? It doesn't tell you where you got wrong. It'll just tell you maybe indexing's off or something, indentation's off or something. It really doesn't explain so much though. They're like the other ones, but it's another exception in Python. So any questions, comments, or concerns about this, just go to gencode.us@gmail.com and just email us your questions and we'll answer them as soon as we can. You could go into the YouTube channel and rewatch this lecture, and you can even go into the gencode.us website and watch this on the Python track. Again, if you have any questions, comments, or concerns, email us. That will be the end of this presentation right now. So hope you enjoyed the presentation. I just do want to show you one quick thing. I did promise you I'll show you what a key error looks like. So let me just go right into PyCharm and I'll show you that right now. And if you want to follow along, you could go into your PyCharm and type in exactly what I'm doing. So just let me give it me a few moments for PyCharm to open up, and I will explain how that key error works in Python. Again, exceptions, very important, right? So if you are not comfortable with them or don't know how to troubleshoot, please understand how each exception works, and please know how you could troubleshoot and fix your code. It's a big thing in Python, right? You really need to know, and not just in Python, actually, in any programming language, you really need to know how to troubleshoot your code. Without troubleshooting, it's going to be very difficult to understand where you're going wrong. So you need to know how you could troubleshoot and how you could fix your code, because you want to fix your mistakes, because no programmer, not even the most expert programmer, is really perfect on anything. It's always going to be mistakes made. So you always need to know how you could troubleshoot and fix those. So let me just use this file. I'm not going to create a new file right now. It's going to show you something. Let me just create a dictionary, right? A dictionary. Remember, dictionaries happen in curly brackets. I think we talked about that in lesson 3. They're different from lists. Lists happen in square brackets. Dictionaries happen in the curly brackets. We talked about in lesson 3 in the data types lesson. So if you didn't check that one out, make sure you want to go back and refresh that on that lesson and check that video out. So let's call it dictionary. Now, a dictionary could be between any types, a string, any immutable type, I think. It cannot be a list, right? Remember, a key cannot be a list. It could be a dictionary, it could be another dictionary, or it could be another string. So let's just call it apple, and and then we'll combine it with a fruit. And let me just show you right on, actually, on my Google, how a dictionary formatting should look like. I don't think we talked so much about dictionaries, so I just want to clear that up on you guys. So I'll just go images and show you basic dictionary. Something like this. This is a dictionary, right? Has a key, right? The key is on the left side of the colon. Then you get the 2 colons, and here's the value of that, right? And this is just showing the ages. So we can do that with same thing with what we're doing right now. So I assigned it to, let's say apple, we'll assign that how many apples we have in the grocery cart. Let's say we have 3 apples, right? And then let's do another one called, I don't know, oranges. How many oranges do we have? Is, let's say 5. And let's say banana. And let's say we have 7 of that. I think this one makes sense, right? Right, so this is telling us the fruit, right? We have a fruit named apple. The key, that's the key. And what's its value? How many apples do we have? We bought 3 apples. Another fruit we bought is oranges. How many of those we have? 5. So that's the value of how many oranges we have. And another fruit we bought, bananas, and 7. That's the value of how many bananas we bought. So again, that's similar to what this shows, right? This is how we write a dictionary in Python. So we wrote that. If I just want to print it, I could just say print dic, right? That's what we call a dictionary. We call it dic. And let's just run this. and it'll print out the dictionary, right? Now, well, if we want to just get part of the dictionary, right, we want to run the key, right? So we want to print, let's say we want to print dic of 0, and we want to get 0, 0. So this is now the 0th value, or whatever the value of that. And we run this will throw back an error, because this is a key error. This is the example of a key error right here. Because look, it's looking for a key 0. So remember, key is always on the left side of the colon. Is there a key named 0 here? No, right? There's a key named apple. There is a key named orange as strings. Again, a key named banana as a string, right? But if there's no key named 0, the only way you could fix that is actually, well, maybe insert a key named 0. So again, these are showing back different kinds of errors, right? There is no key named 0, so we got a key error in that. But there is a key named apple. So if I wanted to get key named apple, get rid of this 3 on the ones. This will just go back. Apple. So it needs to be as a string. We have apple as a string. And it should be. Yeah, that's fine. And now if I run this, this should give back a value of 3. Yeah. So because there is a key named apple existing, and that value is, it's just returning the value of apple, and the value of apple is 3. So if the key exists, it will give back the value of that key. If the key does not exist, like we said, again, key 0, this will get back a key error 0, right? There is no key named 0 in this dictionary. The way you could fix that is just change this to 0. And then now it should get back 3 again, because there is a key that exists as a string 0. So that's a key error, right? Remember, it's important to know how you diagnose it, right? Because that key error told me, hey, there is no key named 0, so you did something wrong, right? So so I went back into the code, and look, I just changed apple to 0, and it gave me back the value 3 again. So that's how you could fix the exception in Python. That's how you do troubleshooting in Python. This was a very simple example, but there's a lot more complicated examples. And you'll experience a lot more in the real world when you actually start working and stuff. So it's very important to know how to troubleshoot your code. So I hope you enjoyed this lesson. I hope you enjoyed the track. This was very fun to learn, and I hope you became expert Python programmers. I do want to know that the capstone project we talked way back in lesson 1, you should be able to do it now. It shouldn't be as difficult, man. It'll use up all these concepts. It might not use up all the concepts, but it will definitely use most of them, right? All the stuff we learned from lessons, all the way from the beginning of this track to the end, it's going to use most of them. It won't use all of them, but most of them. So if you're familiar with loops, conditionals, functions, you should be able to do that capstone project, which was, I think, the rock, paper, scissors, shoot game. So without further ado, I will sign off, and I hope you guys have a wonderful day. Thanks for tuning in, and have a good day. Bye.